Well, greetings and salutations again. See what happens when I get a day off on a holiday in a country that doesn't really matter. So I'm just farting around on the computer today. Um, Man, y'all really shouldn't have pushed me to go over and look at all the ranty stuff. I saw Nathan today arguing back and forth about what we should see in what I am now dubbing as the most worthless flat or globe Earth photograph that exists on the internet. The most worthless one. Okay. So let me go ahead and just show you that to you. Okay. It's this one. Now I heard Nathan argue ad absurdum to exactly what this photo means. Um, there seems to be this new thing going around in flat Earth, or at least on the Nathan side of flat Earth, and that is that things kind of shrink twice, as in they lose angular size, but then they also get smaller. Anyway, out of pure boredom, I lose you. Out of pure boredom, I modeled this out as best I could. Now I got the photo here from Ranty's video, which was just a copy, an excerpt of the piece here from apparently debate 177, blah blah blah. And no, but like I said, it was on today, so I just figured I'd look it up. And the reason why I had to go looking for it is because of the fact that despite my many attempts to ask throughout that hangout, nobody would tell me the distances that were involved here. Now, according to Nathan, in here, the front one, because what I needed to know was the distance to the first one. What is the spread of distance here, and obviously what is the observation height. Now, according to Nathan's words in the beginning of this little video clip here, the the first turbine is 11 miles away, and the third one is, or the last one is 13 miles away. Now he did say about, and I'm going with about. These are not exact measurements. Now, unfortunately, nobody said exactly how tall these things are, so I gave him a nice rounded off 100 meters. Okay, could be smaller. It's not going to make a difference, and I'm going to show you why. So I modeled these things out, and now somebody tell me the difference. First thing I'm going to do is I'm going to show you the results. Uh, Somebody tell me the difference between this. Okay, make a screen cap for those of you who want to. Make a screen cap. And this. Somebody tell me the difference between those two images. The end of the discussion is there's almost no difference. Almost no difference. Now, mind you, yes, on the curved Earth, excuse me, on the curved Earth, there is missing about I think it's like 20 meters down here on the bottom. But seeing that the first one is already missing probably about 10 meters, and you can do these numbers out on the Earth curve calculators all day long. Um, there is no difference between these two images other than very, very minor. Okay, now mind you, both of these are taken with cameras that I put 1 meter above the surface. This one is on the non across a plane. You can also see here the tick lines that go all the way out. There's 100 tick lines along a 5.52, I think it was, kilometer stretch. I did that so I can get a half a degree of curvature. And then this one, you can notice that the lines do not bunch up because they kind of stop here at the horizon. You will not get the same amount, but you can see, because I made the water, the surface level here, semi-transparent. You can see it start to go down. But at 11 miles, you're not going to get much out of this anyway. I mean, you're really not. You're not going to get much out. And like I said, I have this. Let me show you this. This is how I modeled it out. Oops, I'm going to get that out of the way. Okay, these are the two images that I just fired off to you. Okay, both of them with a camera that is 1 meter above the surface. Okay. Now, these things that look like mountains, those are actually just measurement points of kilometers. The high peaks are at 0, then 10, 20, 30, etc. The low peak is at it is the 5 mile increment, and then of course the lines in the middle are the individuals along the way. And yeah, I don't know what else to tell you guys. Um, you're not going to get much difference between the two of them. And in case you're one of those people who wants to say, well, that doesn't look like it dropped off that much. Well, I also did that. What I did was I went down here and I moved 20 meters up. It's actually 20.9 or something like that. So I put this straight line, this green line right here. And this green line goes all the way across. It never actually, hold on. It never crosses the pink line. The pink line is the surface on the curved Earth. The blue line right here, just above it, is across the plane. It never crosses it, ever, at all. So, I mean, so this was just a short video to show that of all the bantering and all the showboating that uh, Nathan loves to do, and don't let me break out the Legos, okay? This makes far more accurate sense, but you know, if I have to break out the Legos, I will. You have to know that uh, there's no observable difference between the two unless you actually had something on the towers themselves, like meter markers or something like that. There's no observable difference between the two, and they would look exactly like this on a curved Earth, and this on a flat Earth. They are basically identical. Okay, so no, don't make me break them out, man. I'm reading you, but don't make me break out the Legos. And now you might say, well, you know, we see more curvature on the Soundly one, and you know, it's greater distance. You know, so what you're saying is that we should only see a straight line. Well, a while back, I modeled out that one too, and it is a greater distance. I don't have the numbers off the top of my head, but come on, open up, open up. Okay, for some reason it's freezing up on me. There we go. This is the view of, this is a 100% accurate, modeled out view of Soundly's original view of the power lines going over Lake Pontchartrain. Now, what I have to do here is actually zoom in a little bit more, because I think the P900 can go down to like 1 degree or like 0.7 degrees or some crap like that. This is what curvature looks like. Now, the piece that the turbines were showing might be about this stretch right here, if that. So you're not going to see any wild bend. And just so you know, 2 miles, I think I even wrote it down just so I didn't quote it wrong. Oh, no, I didn't. I was just did the kilometers and all that. 2 miles, which they said on the turbines was between the front and the back one, you know, 11 miles to the front one, 13 miles to the back one. 2 miles, well, let's just go ahead and do that. Just for a joke. Okay, so just so everybody sees me doing it. Okay, so we already know that in kilometers, the Earth's stated radius or circumference is 40075. We'll divide that by 360. Okay, equals. Oops, did I do that right? I think I forgot a zero there. Hold on a second here. 40075 divided by 360. There we go. 111.319. Now, basically those 2 miles that end up is only 3.2 kilometers of that. Okay, so divided by 3.2 equals, okay, you're getting 34% of a degree of curvature. So I don't know what kind of wild arc you were looking for, even from the side view. Oh, and oh my God, please stop saying orthoscopic view or orthographic view. You don't even know what orthographic view means. Okay, here in this, we even have an orthographic view, which means it removes any and all. See now, unfortunately, that it removes any and all depth or perspective or anything like that. It removes it all. So basically, everything, no matter how close it is or how far it is, will be the exact same width, the exact same height. Period. So that's such a stupid thing to say. But anyway, that's gonna be the end of this one. Somebody just told me that Riley uploaded a video that has my name in it, so I'm gonna take a look at that, and I'll probably be back a little bit later. So, ladies and gents, I hope you guys have a great day.